When I use a word, Humpty Dumpty said in a rather scornful tone, it means just what I choose it to mean, neither more nor less. And the question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master? That's all. I love a good cold open. Howdy, I'm Al Sweigart. I'm mostly known as the author of Automate the Boring Stuff with Python. I grew up in Texas and went to school in Austin. And after a brief 12-year period in San Francisco, I now live in Seattle. But my heart will always be in Texas, as will my cell phone's area code. This is the amazing Mutable, Immutable Tuple, and other philosophic digressions. I'm pre-recording this for PyTexas 2020, so for those watching this in the future, 2020 was an interesting year. So this is a virtual conference, and I'm recording this from my apartment in the Capitol Hill neighborhood of Seattle, which has been a very interesting neighborhood to live in 2020. But to recreate the feeling of a conference talk, I'm going to record all of this in one take with no edits. Now, I make a lot of references and recommendations for books and talks. There's no need to take notes. You can download these slides from bit.ly/amazingtuple PyTexas 2020. This talk grew from a basic question I had. Are tuples mutable or immutable? And the answer is, tuples are immutable. Everybody knows that. Thank you for coming to my talk. Enjoy the rest of your day. Okay, there's more. Let's start this like a philosophical discussion and define our terms. What's a tuple? I'm pronouncing that word both ways, so that way everyone can yell at me and tell me I'm saying it wrong. Well, tuples are like immutable lists. They're an ordered sequence of data. Unlike lists, you type them with parentheses instead of square brackets, but if you only have one item in the tuple, the trailing comma is required. It's really the commas that make a tuple, not the parentheses. Now, for anyone who has read Luciano Ramalho's fantastic book, Fluent Python, you'll know that tuples can serve as more than just immutable lists. But in this discussion, suffices to say that tuples are immutable lists. Next question, what is mutability? Mutable means that it can change its value, while immutable means it can't change its value. So while you can create a list and then change the items in the list, you can't change the items in a tuple. You'll get an error message if you try. So, tuples are immutable. Kind of. I mean, you could just reassign this variable to a different tuple and thus change the tuple, right? Well, no. Technically, this isn't changing the tuple so much as creating a new tuple and replacing the old tuple. But that's an answer that leads to more questions. What's the difference? Why do we even need tuples if we already have lists? And are tuples immutable or not? Now, before we go down that rabbit hole, I want to point out a common Python gotcha. Let's say we create a list and store it in a variable named spam. Then we copy spam to a variable named eggs. And we change the first item in spam to the string changed. What are the contents of the eggs variable? You might know this gotcha already. The eggs list has also been changed, just like the spam list. And this is because spam and eggs are actually referring to the same list. And to understand why that happens, I'm going to use the visualization tool at pythontutor.com. If you've never used pythontutor.com, check it out. It's great at showing what's going on in your code. Here's our 3-line program. At the top is when the first line executes and creates the list for the spam variable. You can see there's a spam variable in blue, and it's pointing to the list object in yellow. And the middle is the second line executing, which copies the list to the eggs variable. Notice that we still only have one list object. It's just that both spam and eggs now refer to it. And that's why at the bottom, when spam is changed, it's changing eggs as well. Now, I used to use a box metaphor for variables, like the variable is a box and the list object is stored inside the box, but that turns out not to work so well for Python. It's better to think of variables as name tags or labels. And these labels point to objects, or they refer to objects, but the object isn't inside the variable. Now in this new example, I've changed the list to a tuple. You still have two variables referring to the same tuple object, but the tuple is immutable, and you'll get an error message if you try to change it. So immutable objects, like tuples, don't suffer from this same gotcha that a mutable list would. Now what about other data types like integers and strings? Well, integers and strings are also immutable. You can assign the integer 42 to spam like we do at the top, and then assign spam to eggs like we do in the middle. And both of these variables refer to the same integer object. And then if you try to change spam, like at the bottom, you're actually creating a brand new string object and attaching the spam label to that. You're not going to run into the gotcha that we have with lists because integers and strings are immutable objects. Now in Python, everything is an object. Lists and tuples and dictionaries are objects, but so are integers and floats and Booleans and strings. But also functions, classes, and modules, all of those are objects. It's not like Java where you have primitive data types and object data types. Everything in Python is an object. And when we assign spam to eggs, we aren't copying objects. And in fact, assignment never copies objects in Python. It only copies the label. And there's a great talk by Ned Batchelder on this called Facts and Myths About Python Names and Values. I draw on some of the things he covers in this talk, but it's worth it to see Ned's talk as well. But keep this in mind, everything in Python is an object. So that's another term that we need to define. What are objects? And I'll get back to this in a moment when I cover the Python object model, but let's look at one more code example first. What happens when we have a tuple that contains a list? So the tuple is immutable, but the list is mutable. And when we change the mutable list, we also change the immutable tuple? How is that possible? Well, let's look at pythontutor.com again. Remember, variables are labels, not boxes, and lists and tuples don't have boxes that contain objects either. They have labels that refer to objects. So pythontutor.com is slightly inaccurate here because this slide should really look like this. The tuple and list don't contain integers and strings, they contain labels that refer to integers and strings. And this view makes it a lot clearer at the bottom that the list changes what objects it refers to, but the tuple doesn't. So the tuple is still immutable. But at the same time, it's clearly obviously changing its value. So does this mean tuples are mutable? What do we mean by these words? Mutable, immutable, object, value. It's easy to use these words interchangeably or inconsistently, but let's think about what we mean when we say them. You can go a long time without knowing the exact definitions. I was programming in Python for well over a decade before I found the data model page in the official Python documentation. Now, the Python data model, also sometimes called the Python object model, describes the lower level details of what Python objects are. Remember, everything in Python is an object, and the Python data model tells us that every object has three things: an identity, a type, and a value. Yay, more words we need to define. An object's identity is a unique integer that never changes for the lifetime of the object. So from the moment the object is created until it's recycled by the garbage collector, it is the same and unique. So in CPython, which is the Python interpreter you download from python.org, the identity is the object's memory address, and that's very convenient because that's an integer that's unique and it's not going to change. And you can find the identity of an object with the built-in ID function. Pass it an object or a variable that refers to an object, and it returns the integer identity of the object. And you can use this to determine if two variables refer to the same object by checking that their identities are equal. And here we can tell that eggs and spam refer to the same list because the object they each refer to has the same identity, so it's the same list object. In fact, this is what the is operator does. It's a shortcut for checking identity equality between two variables. Now, every object has an identity, and every object has a type. And in Python, the terms type, data type, and class all mean the same thing. Like identity, an object's type never changes during the object's lifetime. A type is something like integer or string or tuple. You can find the type of an object with the built-in type function. You pass it an object and it returns the object's type. Remember, everything in Python is an object. And that means that what the type function returns is also an object. And that object has a type. It's the type. Like the identity, the type of an object never changes. If you're converting a string to an int, you aren't actually changing the string's object's type. What's happening is that you're creating a new int object, and the variable now refers to that new int object. And we can see this for ourselves by checking the identity of the variable's object. The ID function here gives us different identity numbers. Now, every object in Python has an identity, a type, and the third thing is a value. This is the most familiar property. The value is one of a range of values determined by the type. So there's effectively an infinite number of possible integer and string values, but the Boolean type only has two possible values, true and false. And the none value is the only value in the none type. So is there a built-in function to tell us the value of an object? Well, we think of value as this well-defined thing, but when I looked closer, value is kind of nebulous. I'm going to ask a question that sounds like it's straight out of philosophy. What is value? Now, if you want to see an object's identity, you can call the ID function. If you want to see an object's type, you can call the type function. But if you want to see the value of an object, there are actually two built-in functions, stir and repr. The stir function, or string function, returns a human-readable string form of the object's value. This is straightforward for objects like integers and strings, so let's use a more abstract example with the datetime.date object. Here I have called datetime.date to create a date object that represents January 20, 2020. And I assign the birthday variable to refer to this object. Now, when I call string, it returns a string of a human-readable form of the object's value. What string or stir returns is defined by the datetime.date type. But this string of the object's value is not the same thing as the object's value. If we try to use the equality operator on them, it evaluates to false. Stir doesn't return the object's value. It returns a string that represents the object's value, and that's a subtle difference. The other built-in function for seeing an object's value is repr. The repr function produces a string that ideally is a representation of Python code that would recreate the object with that same value. So passing the date object to repr gives you a string of the code that creates the date object. Now, the reason we have two different functions is because the stir string is useful for displaying object values to humans, while the repr string is useful for more technical contexts like log files or debugging messages. And this isn't always possible to make a repr string of Python code to recreate the object. For example, I've created a foo class here, and the default implementations of stir and repr are fairly useless. You can tell from the angle brackets that this string would not be valid Python syntax. You couldn't recreate the object using the repr string. The stir and repr functions return strings that describe an object's value, but that's not going to be the same thing as the value itself. Even if we type the variable that refers to the object into the interactive shell, that's just going to show us the repr function's string. That's not going to be the object's value itself. Now, we need to know the value so we can tell if an object's value changes, and then we can find out if the object is mutable or immutable, and then we can find out if tuples are mutable or immutable. So this is getting kind of complicated because mutability isn't a property of Python objects the way identity, type, and value are properties of Python objects. Now, let's look at the Python data model documentation again. It tells us that if an object's value can change, it's mutable, and if it can't, then it's immutable. But that doesn't tell us an exact definition of value. I did eventually find it. It's in a completely different section of the Python documentation, section 6.10.1. It has this line: the value of an object is a rather abstract notion in Python. Yeah, no kidding. But it says that the value of an object is dictated by the equality operator. And I agree, but even if this wasn't backed by anything in the official Python documentation, I think I could make a pretty good case for this. For example, the integer 42 and the floating point number 42.0 have the same value. The equality operator says they are equal. Now, I can't tell you the true nature of the value 42. I'm sure it has something to do with life, the universe, and whatever. But however you want to define value, I can tell you that these objects, 42 and 42.0, have the same value in Python. Meanwhile, the integer 42 and the string 42 have different values. The equality operator says their values are different. But if you want to know something kind of weird, the Boolean true and false values are the same as the integer 1 and 0 values. The story behind that is Python originally didn't have a Boolean data type. It was added later, and when they added it, it was just easy to make Booleans a subclass of integers. So you can use Boolean values anywhere you can use the integers 0 and 1. And that means you can mathematically add true plus false plus true, and that evaluates to the integer value 3. You can use true as an index of a string and get a substring. Now, you can write code like this, but please don't. It's completely unreadable. But if you want to know something that will really bake your noodle, check out Python 2. Capital T true and capital F false were only made keywords in Python 3. In Python 2, you can use these names as variable names, which means you can assign false to true, and then true is false is true. So please switch to Python 3 if you haven't already, because otherwise you might destroy the space-time continuum or something. So if mutability is based on value, and value is based on the equality operator, what is the equality operator based on? And that's easy to answer: the dunder equal dunder special method. Now, Python classes, which is to say Python data types, have special methods that begin and end with double underscores. We call them double under methods, or dunder methods. The dunder equal dunder method overloads the equality operator. So say I have a cat class, and I define a cat as being composed of a color and weight. Now, in reality, cats are much more than just color and weight. Don't confuse the map with the territory. But this is just how I'm defining cats here in this class for this particular piece of software. Now, I'm overloading the equality operator so that another object has an equal value to this cat object's value if its type is cat or a subclass of cat, and it has a matching color and weight. So I can create two cat objects and assign them the variables Zophie and Puka. When I compare them with the equality operator, Python calls dunder equal dunder, and it returns true. So these two objects have the same value because the equality operator says they do. Though I can change that as much as I want. Let's change the dunder equal dunder method so that two cats have the same value if they have the same color, and weight doesn't factor into it at all. Then I can create two cat objects, Zophie and Jasper, and these cats are both gray but have different weights. But Python considers them to have the same value because the value of the weight attribute isn't a part of the value of the cat object. Now, that seems quote-unquote wrong, but maybe this fits the requirement for this particular cat class in this particular piece of software. Let's take this even further. If I always return not other is self, then a cat object has the same value as literally every other object except for itself. So Zophie is not equal to Zophie, but Zophie is equal to the string cheese sandwich. Now that seems very wrong, but this is Python programming. There is no right or wrong. There's only dunder methods. I can't think of a case where code like this is necessary or useful. It also breaks dictionary hashing completely, but if the use case demands it, then this is the quote-unquote right definition of value for this class. There doesn't seem to be a consensus on what value is in the Python language. You could argue that the integer 42 should have the same value as the string 42, but the equality operator, that is, the class's own dunder equal dunder method, says they don't. And I think what a type says about its own definition of value is the closest thing that we're going to get to a referee on this. I will now tell you if tuples are mutable or immutable. We have two tuples, spam and eggs, and they have separate identities. They are different, separate objects. The equality operator says they have the same value, though. So no matter what you say about the nature of these tuples values or of value itself, we know that they are the same value according to the equality operator. Now we run this code and we change the list inside the spam tuple. And when we compare their values again, they do not have the same value. Therefore, one of these tuples must have changed their value. Therefore, tuples are mutable. This is the part where someone says, yeah, Al, but tuples are immutable. Everybody knows that. That someone will then point to the Python data model documentation and say that the tuple is still considered immutable because the collection of objects it contains cannot be changed. Yep, I mean, I can't argue with that. I even showed that in my earlier example. The Python data model documentation continues. So immutability is not strictly the same as having an unchangeable value. It is more subtle. It is more subtle. I spent weeks on this presentation trying to show that tuples are mutable, and it gets refuted by 4 hand-waving words in the documentation. The question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master? That's all. We can argue about what mutability means in Python because ultimately humans define words and not the other way around. Maybe we're thinking about mutability wrong. Maybe I'm thinking about mutability wrong. Maybe the Python documentation is wrong. Maybe data types like tuples aren't mutable or immutable, but individual objects are mutable or immutable. And that could be a whole other talk, but I'm running out of time, so I'm going to leave you with one final philosophical question. How many colors are in a rainbow? 7, right? But this isn't a rainbow. This is. So how many colors does it have? 1 million? Infinite? Well, it depends on how you define color. But a small-minded person might say, no, rainbows have 7 colors. They can only have 7 colors. We all learned this in kindergarten. The colors of a rainbow are Roy G. Biv, red, orange, yellow, green, blue, purple, and a different kind of purple. Maybe these two words, mutable and immutable, aren't as concrete as we first thought. It's more subtle than that. Maybe having just 2 words isn't enough to fully describe Python objects. Or if we do use these 2 words in a casual colloquial sense, that isn't the final sense. Well, I'm a programmer and not a philosopher, and I've been talking for 25 minutes, so maybe it's time for me to listen to what others say about what identity, type, and value means to them. Thank you very much. We'll meet again. Don't know where, don't know when, but I know we'll meet again some sunny day.